Welcome to the last part of Module 4 Stereochemistry, that is Conformational Analysis 2. Now we move on to the conformations of substituted cyclohexane. A substituted cyclohexane means the hydrogens are replaced by some other groups. So let us see what are substituted cyclohexanes. Substituted cyclohexanes are of two types. We can have mono-substituted cyclohexanes and di-substituted cyclohexanes. We will be seeing only these two cases, mono-substituted and di-substituted cyclohexanes. And we will be only looking at methyl substitution. So only the functional group that is substituting hydrogen is. Let us start with the conformations of methyl cyclohexane, monomethyl cyclohexane. So one of the hydrogens is substituted by a methyl group. So what are the different conformations that are possible? So this is one conformation where the axial hydrogen is replaced by a methyl group, and this is called the axial methyl cyclohexane, axial methyl conformer. And in this case the equatorial methyl group, hydrogen is replaced by a methyl group. So this is called equatorial methyl cyclohexane. So these are the two conformations that are possible, the axial methyl cyclohexane and equatorial methyl cyclohexane. Now looking at the stability of these two conformers, you can see here the axial substituent. When the methyl group comes in the axial position, it can undergo 1,3 diaxial interactions. Okay, diaxial interactions with the hydrogens of position of carbon 3 and carbon 5 respectively, because both are alternate carbons respect to carbon 1. So there are two diaxial interactions that are taking place here, and so the potential energy of the axial substituent is higher, and the equatorial substituent, there is no such interaction. So this is the more stable conformer. Coming on to conformations of dimethyl cyclohexane. In case of dimethyl cyclohexane, there are 4 different isomers that are possible. Okay, dimethyl substitution can happen in 4 different positions in cyclohexane. That is 1, 2, 1, 3, or 1, 1, 1, 2, 1, 3 and 1, 4 positions. Let us. This is 1, 1 dimethyl cyclohexane. Both the hydrogens of carbon 1 are substituted by methyl groups. Then you have 1, 2 dimethyl cyclohexane, where 1 and 2 positions are replaced by methyl group, dimethyl cyclohexane, and 1, 4 dimethyl cyclohexane. So 4 cases we have to consider. Let us see that one by one. Conformations of 1, 1 dimethyl cyclohexane. When both the methyl groups are in the same carbon, then what are the different conformations? So this is one conformation, axial and equatorial. This is called as 1A, 1E dimethyl cyclohexane. 1A, 1E dimethyl cyclohexane. Now here both the methyl groups are on the same carbon, and so this is the situation. So now there is an axial methyl group here. So this axial methyl group will undergo diaxial interactions with other hydrogens, and so the stability of this molecule will be medium. Okay, there will be of medium stability. Now if you flip this cyclohexane ring, you will get the same isomer, 1A, 1E itself. You will get the same isomer. So there is only one conformer in case of 1,1-dimethyl cyclohexane, that is the 1A 1E dimethyl cyclohexane. Coming to the 1,2-dimethyl cyclohexane, what are the different conformations in 1,2-dimethyl cyclohexane? 1,2-dimethyl cyclohexane exists in two forms, that is the cis form and the trans form. This is the cis form, this is a trans form. So each of them, cis and trans, they can have different conformers. So we will see the conformers of cis form first, and then we will move on to the trans form of 1,2-dimethyl cyclohexane. Now cis form of 1,2-dimethyl cyclohexane exists in two conformers. These are the two conformers. So in the first case you can see 1A, that is in the 1 position the methyl group is in axial, and in the 2 position it is equatorial. Okay, this is the cis 1A2E dimethyl cyclohexane. Whereas in the other isomer you have 1E and 2A, 1E 2A cis dimethyl cyclohexane. Now in these two cases there is one axial substituent, and so there will be diaxial interactions, and so the potential energy or the stability will be medium stability for these two, and in these two cases the stability is equal for these two, that is 1A2E and 1E2A isomer. The stability is equal and it will be medium stability. Coming on to the trans, you have two forms, this 1A2A and 1E2E respectively. You can see here in both positions the methyl groups are axial, that is 1A 2A, and here in both positions the methyl groups are equatorial, 1E 2E. Now if you compare the stabilities in these two cases, we can see here two axial substituents are there. So these will undergo diaxial interactions. Okay, so this group will also undergo diaxial interaction. This methyl group also undergoes diaxial interaction, and so the stability will be minimum, or potential energy will be maximum in this case. Whereas here both are equatorial, and so there are no diaxial there are no other interactions, and this one will be having the most stability, this one will be having the least stability. So in case of trans 1,2-dimethyl cyclohexanes, the 1A2A has least stability, 1E2E has maximum stability. Now, in case of 1,3-dimethyl cyclohexane, again there are two isomers, cis and trans. Okay, 1,3, the positions are different. 1,3-dimethyl cyclohexane. Now, in this we will see again cis and trans separately. So, cis there are two forms. This is 1A3A and this is 1E3E form. So, if you compare, if you look here. So 1A, 3A, in both these positions the methyl group is axial, so it will undergo diaxial interactions. So this molecule will be having very high potential energy, but here the potential energy will be minimum because there are no diaxial or other types of interactions. So here in 1A, in the 1,3-dimethyl substituents, the 1E3E, cis 1E3E is the most stable, and cis 1A3A, that is the least stable conformer. Okay, cis 1E3E is most stable and cis 1A3A is least stable, because in 1A3A there are maximum diaxial interactions, and so less stability. In 1E3E there is no diaxial interaction, so maximum stability. In the trans isomer we have two types, 1A3E and 1E3A. So both have one axial substituent each, and therefore the stability will be medium, because in each case, say in this isomer there is one axial substituent, So there will be diaxial interaction. Here also there is one axial substituent that is at the 3 position that will undergo diaxial interaction. So the stabilities of these two will be equal, and compared to the others it will be medium stability. The last category, conformations of 1,4 dimethyl cyclohexane. Again, this is cis 1,4 and this is trans 1,4 dimethyl cyclohexane. So we have to see them separately. Cis has 2 conformations, trans has 2 conformations. Now coming to the cis, this is the one conformation, it is called 1A4E, and this is the other conformation, it is called 1E4A. Now in both these cases there is one axial substituent, and whenever there is one axial substituent there will be diaxial interactions. So stability of these two are equal and it will be medium stability compared to the other forms of 1,4 dimethyl cyclohexane. Moving to the trans again has 2 forms. It is 1A4A and 1E4E. So from this it is evident there are 2 axial substituents here. So there will be diaxial interactions, and so this compound will have minimum stability, whereas here both are equatorial and so there is no other interaction. This compound will have maximum stability. 1A4A will have minimum stability. So these are the different conformations of 1,4 dimethyl cyclohexane. Now let us look at the whole thing in a single sheet. You can see the conformer, least stable, medium stable and most stable. So here 1,1 dimethyl cyclohexane, there is only one form and that has medium stability. In the other cases 1, 2, 1, 3 and 1, 4, you are getting 4 different conformers, 2 cis and 2 trans. Okay. Now if you look here, the 1, 2 and the 1, 4, they show some similarity because the trans AA in both cases it is a least stable, and the trans EE in both cases, trans EE is the most stable, whereas the cis forms have medium stability. Okay, that is for these two cases, 1, 4 and 1, 2 also. In 1, 3 it is just the opposite. The cis AA has least stability, cis EE has more stability, the trans forms have medium stability. So that is one comparison. Okay, in 1,1 dimethyl there is only one isomer that has medium stability. In the others there are 4 isomers. Out of them in 1, 2 and 1, 4 the trans AA has least stability, the trans EE has more stability. In 1, 3 the cis AA has least stability, the cis EE has more stability. Similarly, medium stability in 1, 2 and 1, 4 both the cis isomers have medium stability, and in 1, 3 the trans isomer has medium stability. So this is conformational analysis of ethane, butane and cyclohexane and substituted cyclohexanes.